we've got syllabus quiz today, and for the syllabus quiz, you can use what resource? Your syllabus, but you have to bring your syllabus with you, right? So make sure you have your syllabus with you. Okay. Make sure that all electronic devices are turned off and put away right now. Okay. No electronic devices are allowed out during class. This includes the computers on the desktops. Everything needs to be put away, turned off. Your phone can be on silent. That's fine, but it needs to be put away. Right. Next time we have two quizzes. Next lab, the PsycInfo database quiz, which is based on the port tutorial that you did over the weekend, and you're going to do a workshop today in lab, so in practice, to make sure you know how to do stuff with that. You're also going to have an APA style quiz next week. That's based on the APA tutorial. That's homework for this week. For both of those quizzes, you can have one 4x6 note card with handwritten notes on one side as a cheat sheet from the tutorial. Yeah.
I know you're going to listen to the style guide. Is this like a...
Yep, that's it. That's it. That's the one you want.
Okay.
That's it. That's the blue book. That's the book to get.
Like 5 years.
Yeah, that's the one. Well, there you go. See, you didn't have to get anything new. Fantastic. All right, so for the quiz, though, you can use one 4x6 note card with anything you want to put on one side. Okay? You can make one card for the APA quiz, one card for the PsycInfo quiz, and you'll turn those cards in when you submit your quiz. Okay? You don't get to keep your card. So keep in mind, anytime you prepare a note card for a quiz or a test in this class, you need to make sure that you take a picture of it or you scan it or whatever you need to do so that you have a copy of it if you want to use it as a study tool later on. Okay? But everybody gets to use one 4x6 note card on the APA quiz and one 4x6 note card on the PsycInfo quiz. You don't need a note card today because you actually get to use the syllabus for the syllabus quiz. All right, so that's next week in lab. So you got make sure that you study for those two quizzes for next week. That'll be all. That'll be 4 of our 5 lab quizzes. The last lab quiz after that will be the plagiarism quiz, and the way you complete the plagiarism quiz is you go online and you do the how to recognize plagiarism tutorial and quiz. And when you complete that quiz, successfully pass the quiz at the college level, then you'll get a screen will come up that will have a completion certificate that you can print out, download and print out. And you have to download, print that out, and bring in the completed hard copy and turn it in by the deadline listed in the syllabus, and that's how you get credit for the plagiarism quiz. I think the deadline for that is October 7th, I think. But I have to check the syllabus. Okay, it's listed in the syllabus. All right. So then our 5 lab quizzes will be done. Okay, does anybody have any questions about that? We good? Yes?
Can we turn in our hard copy of the printout prior to the deadline? Do you want us to
It's actually easier if you save it and turn it in on the deadline day so that it doesn't get misplaced. Because I collect 50 of them, and if they come in scattershot, then it's more likely that something's going to get lost. And I would also encourage you to download, when you download that to your computer, save it so that if there's a problem and something gets lost, it will still be on your computer. You can print out another copy because when you download it, it actually time date stamps when you downloaded it. So then I'll be able to see when you completed it to see that you got it on time in case something gets misplaced. Yeah.
What if I did it for a previous class? Can I turn that one in? Or would you like us to
do it again because the test is changing.
Okay.
So I want you to do it again. All right. Any other questions about that stuff? Good? Okay. So today in lab will be workshop with Ida Martinez, the psychology librarian, practicing with PsycInfo syllabus quiz. 2 hours of exciting research methods fun. Yeah, I know. Woo! Just what you wanted to do after the long weekend. All right, so today we're going to talk about experiments, get started talking about simple experiments. And I'm going to put this down, it will help with video capture. Okay, so as we talked about last time, experiments are designed to establish causal relationships between variables, specifically between an independent variable and a dependent variable. There are 3 requirements for establishing a causal relationship. You have to have a correlation between the variables. So we have to see that change in the independent variable is correlated with change in the dependent variable. Okay? They have to co-vary. There has to be some connection between the ways that they change. There has to be clear directionality. Okay? A clear time-order relationship. Your book calls this temporal precedence. Okay? Meaning that change in one variable must occur earlier in time than change in the other variable. So you have to have a time-order relationship where one changes before the other. Specifically, the independent variable has to change before the dependent variable changes. And it must be in that order. The third thing that has to be true is you have to have an absence of other explanations. So any other variables that could be explaining the change in the dependent variable have to be eliminated from contention. In other words, we have to make sure that our study has high internal validity, and there are no confounds that could be getting in the way of us making a causal claim about the relationship between the independent variable and the dependent variable. Now, if there are variables that are not my independent variable, and I can imagine that they could feasibly influence my dependent variable, then I need to control them somehow. And I really have two options for how I can control them. Well, three options. I could make them another independent variable in my study and manipulate them on purpose. But that would make my study more complicated. If I want to keep it a simple experiment with an independent variable and a dependent variable, just one of each, then my alternatives are to hold that third variable constant, in other words, turn it into a constant, or balance the variation across the conditions as much as possible. Let me explain what I mean by those two things. So say that I'm doing a study where I am having dogs eat different brands of dog food to see which food they like the most. I'm going to measure how much of each food the dogs eat. Well, if I'm concerned that the size of the dog will influence how much it eats, which makes sense, right? Bigger dogs eat more food than smaller dogs. Okay. Then what I might choose to do is hold the breed of dog constant to limit the size. So maybe I'm going to go with all bulldogs because they're the best dogs. And I'm going to go with all bulldogs, hold that constant, and that way I'm working within a reasonable range of maybe 10 pounds of dog, and if I hold that breed constant, that's going to minimize the influence that the size of the dog could have on my dependent variable. Alternately, I can balance those third variables across conditions, meaning, so say I have, I can't just get bulldogs because there aren't enough bulldogs to participate in my study. So instead, I have several different breeds of dogs. Well, what I want to make sure is that I don't end up with a situation where all of the big dogs are in one food condition, or most of the big dogs are in one food condition, and most of the small dogs are in another food condition. Because if all the big dogs are in one food condition, they're just naturally going to eat more than all the small dogs. So what I want to do is find a way to mix up the sizes of the dogs in every condition. I want to balance it out so that I have some large dogs in every condition, and some medium dogs in every condition, and some small dogs in every condition, and roughly the same number of each type. And by doing that, I'm distributing or balancing that particular characteristic of size across the conditions so that if size does impact how much food a dog eats, it impacts each of the conditions about the same. So it's a wash and it doesn't matter anymore. So again, 3 ways that you can control a variable. You can either turn it into an IV and manipulate it. You can turn it into a constant and control it that way. Or you can balance it across the conditions so that the impact of the variation is evenly distributed across all the different groups. Does anybody have any questions about that? Make sense? Okay. So, let me just go ahead. Now, all experiments have covariance. When we design an experiment, we design it so that it has, theory-driven relationship between the independent variable and the dependent variable. We don't just arbitrarily slap two variables together and do an experiment. So it's going to be some theory-driven or model-driven relationship between the two variables. So we're going to have covariance. And we just naturally get directionality because we don't even measure the dependent variable until we've done something to the independent variable. So we never, we always have change occurring in the independent variable before we measure anything in the independent variable. So we've got that covariance thing and we've got the directionality thing pretty much down, as long as we do an actual normal experiment. As I mentioned last time, only some experiments allow the researcher to have sufficient control over the independent variable that we can call it a true experiment. A true experiment is one that has a manipulated IV, one for which it's possible for the researchers to randomly assign the subjects to conditions. And only that is a true experiment. Those are the only kind of experimental designs that allow us to establish a causal relationship. If instead of a manipulated IV, I have a subject IV, a variable that reflects naturally existing groups, then I don't have a true experiment, I have a quasi-experiment. And I can no longer make a true causal claim. Now this doesn't stop people from doing it. For example, people will say that smoking cigarettes causes cancer. But we don't actually have any experimental evidence from a true experiment that shows smoking cigarettes causes cancer in humans, because it would be unethical for us to take a group of subjects and then randomly assign half of them to start smoking cigarettes, have them smoke for 10 years, and see if they develop, or 20, or 30, or 40 years, and see what health problems they develop as a result of being randomly assigned to the smoking condition. We can't do that. So we have experiments that have been done, true experiments that have been done with animals that show that there's a causal relationship. And we have quasi-experimental studies that have been done with humans, where, for example, we have twins, where one twin smokes and the other twin doesn't. And they look to see the likelihood that the twins who smoke are developing different kinds of smoking-related illnesses compared to the twins that don't smoke. Or even just regular people, siblings, who've grown up in a similar environment and are close in age. One who smokes, one who doesn't. But those are quasi-experimental because the people can't be randomly assigned to the different conditions. They come into the study being a smoker or a non-smoker. So we can't really make a causal claim in that case, but the converging evidence across animal studies and human studies and simulations and things like that gives an abundance of evidence that still leads people to make the causal claim about smoking causing cancer in humans. But it takes a lot more work to make that kind of causal claim because we can't do the true experiment with human beings. Now, subject variables are sometimes referred to as individual differences variables because they reflect naturally existing individual differences that people have. And everybody has some combination of differences that makes them unique compared to other people. Even twins and triplets and quadruplets are different than their siblings in some ways. So everybody has individual differences. So these are sometimes called individual differences variables. They're sometimes also called natural groups variables because they reflect naturally existing groups. Like, I'm a Republican, I'm a Democrat, I'm Green Party, I'm a socialist, I'm a communist, whatever. Those are naturally existing groups. People already belong to them, and we can compare people who belong to those different groups. So if I say subject variable, individual differences variable, or natural groups variable, I'm talking about the same thing. Now, people sometimes struggle to tell the difference between a manipulated IV and a subject IV. So just some things to look for. Manipulated variables are created. The researcher gets to define the levels. The researcher gets to choose what groups are going to be compared And the researcher has the ability to randomly assign subjects from the sample to the conditions. So every single person that's drawn out of the population and brought into the study has an equal chance of being in any of the conditions created by that variable. When it comes to a subject variable, the researcher doesn't control who is in the groups. Beyond saying, I choose, these are the groups that I want to compare. I want to compare males and females, for example. And then I'm going to recruit people who already have that property. And they're going to participate in my study. I cannot randomly assign someone to the female group today, or randomly assign them to the male group tomorrow. I don't get to do that. So if I'm simply selecting people from the population because they have the property I already want, then we're talking about a subject variable. But if I just select people and then randomly assign them to the conditions that I made up, then we're talking about a manipulated variable. But it's not possible to randomly assign people to the levels of a subject variable. You just can't do it. Because they have to already have the characteristic. It's part of what a subject variable is. And these notes are posted online, so you will be able to get these exact PowerPoints from Desire to Learn. Okay, so all experiments, whether they're true experiments or quasi-experiments, have, at minimum, one independent variable and one dependent variable. The independent variable has to have at least 2 levels. Otherwise, it's not variable. If it only has 1 level, it's not a variable, it's a constant. So the independent variable has to have at least 2 levels. And independent variables are typically measured on nominal and ordinal scales. You will see some on other scales. But if you see something that's measured on a nominal scale or an ordinal scale, you can be confident, pretty confident that's an independent variable. Because we just don't measure dependent variables on nominal and ordinal scales very much. When it comes to dependent variables, we're talking about interval and ratio scales. Do you guys remember the difference between all these different types of scales? What's a nominal scale? Categories. Just names, just categories of things, right? No order, they're just groups. They can go in any order, doesn't make any difference. Like if I said Republican, Democrat, Independent, Green Party, Communist, Socialist. Doesn't matter, I can put it in alphabetical order, I can put it in whatever order I want. Doesn't make any difference. They're just groups. No particular order. An ordinal scale has what that nominal scales don't? Order, right. So there's some order to the scale. First, second, third, fourth, fifth. Fastest, next fastest, third fastest, fourth fastest. Most attractive, next most attractive. Least attractive, right? There's always some order. Okay? But the order is not standardized. What I mean by that, well, I should say the units are not standardized. So the difference between the fastest person in a race, whoever was in first place, might be 1/10 of a second faster than the person who was second in the race. But the third person might come in a full second later. And the fourth person might come in 2 seconds later. They're still first, second, third, and fourth. Right? So the distance between the different ticks on the scale is not equidistant. It's not standardized. It may not even represent a known unit. So for example, if we're talking about attractiveness, I can certainly identify different rank orders of attractiveness. Most attractive, that would be yes, please, right? Up there on the top. Down at the bottom, least attractive would be no, thank you, right? Down on the bottom. And somewhere between no and yes, there are all different levels of attractiveness, right? Down here you might have, you know, my other class was talking about things like down at the bottom, so you have no, thank you. And then right above that, what might you have? What's a little bit better than no? That's exactly what they said. I love it. They're like, it's Then right above that is maybe, I don't know, nice personality. Something, right? And then you get above that. Kinda. What's above kinda?
Possibly.
In a weird way.
In a weird way. Okay, possibly. All right. And then what's above that? Attractiveness.
I'll give it a try.
Give it a try. Maybe with beer or something, right? You know, something like that. With beer. Okay. And then above that. Maybe. Okay, sure. Yeah, all right. You know, and you're moving up, but you can see that we can, you know, you're talking about levels of attractiveness, and you might get things like, oh, the person is beautiful, the person is gorgeous, the person is handsome, the person is hot, right? We have all different labels for different kinds of attractiveness. And you could kind of figure out, if we sat here and talked about it, we could probably rank order all the different terms for attractiveness we could think of. But the distance between those units, like the distance between, yes, please, and oh my goodness, right? Those were the top two levels. If the distance between those is probably not the same as the difference between oh my goodness and whatever's right below that, right? So they're not equidistant. It's also the case that what is my yes please might be your right? Depends on what your type is, right? Depends on what you like. So you might say, you know, you might rate somebody as being really attractive, and I might be like, yeah, it doesn't do it for me. Right? That's just not my thing.
No constant.
So there's no, it's not clear, even if we both rated, you know, we could rate the same person and have totally different numbers, right? Totally different values for them. And it also changes. I mean, think about who you thought was attractive when you were like in 4th grade. Right? Your criteria have changed. I hope. Right? I hope you're valuing different things now than you did in 4th grade. Right? 4th grade, it was like, you know, who had the best seat in the lunchroom or something like that, right? You know, who's going to save you the best seat in the lunchroom? Or who has the nicest pencils? Or something like that. You know, I mean, you have different standards. Now, as adults, hopefully you're looking for something else. So, it varies. Each individual person is going to rate things differently. And so it's not even really clear if someone says someone's really attractive, well, what does that mean? Attractive how? According to what criteria? So ordinal scales are super smushy. They're really, really smushy. They have rank order, but they're really, really smushy. Now what's an interval scale?
The difference set.
That's where we've got a standardized difference. So now we've got the categories, we're adding order, but now we're making the units equidistant from each other. So now I know how far something is apart from something else, for sure. So, you know, 1 degree Fahrenheit, if there's a difference of 1 degree Fahrenheit, I know how much that is, right? 35 degrees Fahrenheit is the same distance from 34 degrees Fahrenheit as it is from 36 degrees Fahrenheit. I know what that unit is. What's the difference between an interval scale and a ratio scale? That's right.
Yeah.
Ratio scales have everything that interval scales have, but they also have what we call true zero, or absolute zero. So 0 really means 0 in this case. So if we talk about degrees Fahrenheit, that's an interval scale, because even though it has standardized units, 0 degrees Fahrenheit doesn't mean it can't get any colder. Right? We can get -5 or -10 degrees Fahrenheit. If you ever lived any place north of here, you've experienced that, right? Here we don't usually get down that cold. Here it gets to, 40 and people are like, we're in the Arctic! I'm like, no, we're not. I promise. I grew up in the Rocky Mountains. It's not that cold. I remember when I was teaching at Ohio State and I had to go across campus and teach and it was -20. Ooh. And I had to go to work and I was teaching a 7:30 in the morning class. Let me tell you, there was like nobody in that class. I'm like, why am I here at 7:30 in the morning? People's cars wouldn't start. I mean, everything was just frozen. And they're like, it's Ohio, we can handle it, let's go. So it can get much colder than 0. But if we're measuring on a Kelvin scale, 0 degrees Kelvin is absolute 0. It cannot get any colder than 0 degrees Kelvin. There's absolutely no heat whatsoever at 0 degrees Kelvin. So that's a ratio scale. All right, so when we're measuring a dependent variable, we tend to measure them on interval and ratio scales because those are the dependent variables we want to do math on. That's what we want to crunch numbers on. We want to calculate means. and standard deviations and things like that. And we can't do that unless the numbers mean something, right? If I'm going to say that the average in this condition was 5, well, I have to know what that means. And so I have to have a standard unit of measure for that to be a truly meaningful thing to do. Now, in psychology and other social sciences, we cheat a little bit, in some cases, by creating something that we call an almost interval scale, which is really just a fancy way of saying an ordinal scale that we slap numbers on. So say I have a scale like very dissatisfied, dissatisfied, neutral, satisfied, very satisfied, right? The classic Likert scale. Now, it's not clear. That's an ordinal scale. Because my satisfied could be your very satisfied, right? I could have different standards, and what I think is what my personal experience of satisfaction may be what you describe as being very satisfied, but it's different for me. And it's not clear how far apart being very satisfied is from being satisfied. So, since we don't know, that's the unit difference, and it's going to be stretchy, it's going to vary for different people. That's an ordinal scale. But as psychologists, we like to ask people about things like this. So we want to ask them how satisfied they are in different situations. We want to ask them how depressed they are, or how anxious they are, or how happy they are, or how frustrated they are. And there is no unit of frustration. There is no unit of depression. There is no unit of anxiety. So we have to say, all right, we're going to give you on a scale of 1 to 10, where 10 is I'm extremely anxious, and 1, I'm not at all anxious. Where are you? And what we've done is created an almost interval scale. So now people are kind of going up and down this number scale and circling where they think they are, and we're acting like the 6 really means 6. But it doesn't really mean 6. It just means more than 5 and less than 7 for this person at this time. So it's still a super smushy measure, but we're treating it like it's a real number. And that's what I mean when I say an almost interval scale. When I take an ordinal scale and I slap numbers on it so that I can do some calculations, those calculations, honestly, are pretty meaningless, because the numbers aren't really numbers. They're just rank order labels. And your 5 might be my 7. But that's not true, right? If I count how many pens I have right here for everybody, it should be 4, right? 4 should be 4 for everybody if it's really a number, right? But here, I'll give you your pens back. So, but if we're talking about 4 on a scale of depression, it just means you're kind of less than middle of the road, but not all the way down in the pit, right? If you've ever been depressed, you know exactly what I'm talking about, right? Or if you're 4 of anxious, it means you're kind of a little bit less than the middle, but not super, super anxious, or not totally non-anxious. So 4 doesn't really mean 4. It's just a label. You might as well be somewhat anxious. It means basically the same thing. But sometimes in psychology, we do that for dependent variables. And when we do, keep in mind, it means that the math we're doing is kind of a cheat. And you have to be very careful how you describe what those numbers mean. Because to say that someone is significantly more attractive than somebody else, well, really? Is that really a mathematical claim you can make? Because, beauty is in the eye of the beholder. So you might say this person is significantly more attractive, and the math might say that the person is significantly more attractive, but a whole different group of people might say, no, not attractive at all. Just does not do it for me, and the person wouldn't be attractive at all. So it's very squishy, very flexible. And you have to keep in mind, are we talking about real numbers, or are we talking about fake numbers? Now, each level of the independent variable can also be referred to as a treatment or a condition. I'll use those terms interchangeably. So if I talk about levels, treatments, or conditions, I'm talking about different groups that are defined by the independent variable. And when I talk about these levels, let me fix this. This always drives me crazy. It always does this when I load it up. When we have an independent variable, if it has just 2 levels, you will have, at the very least, an experimental group and a control group. Okay? The control group is the comparison group. It's the group that you're using to show kind of a neutral state that you can compare the experimental group to show that your treatment, the manipulation you did, actually had an effect. And it actually did something different than the normal state of affairs. Now we can actually identify a variety of different kinds of control groups. And you need to be able to recognize different kinds of controls. And it's possible, I'll say up front, to have more than one kind of control in a single study. Because they're all just different kinds of baselines. They're giving us different kinds of information about the normal state of affairs. Now the simplest kind of control is something we call a no treatment control. This is where we don't do anything to the people in that group. So for example, if I was doing a simple experiment where I was injecting rats with testosterone to see if it impacted their aggression, made them become more aggressive if they received an injection of testosterone. I could have one group that got no testosterone, and I just observed them to see how many times they bit other rats in their enclosure over a 5-minute period. And then I could have the group that I injected with testosterone, and I looked to see how many times they bite other people in their enclosure, other rats in their enclosure, in that 5-minute period, and compare the two groups. It's a no treatment control because I'm not doing anything to that group that doesn't get an injection. I'm just letting them be rats, so I'm not doing anything. So it's no treatment at all. It's just live your life, do your thing, and I'm going to observe how often you do the thing I'm interested in as a dependent variable. Now, placebo control is used often in psychology studies, and this is where you do something to make it seem like the control group is getting a treatment, some kind of experimental treatment, but in fact they're not. So, for example, if I had my group of rats and I had one group that got an injection of testosterone, and the other group just got an injection of saline. They're not really getting an injection of any kind. I mean, of any kind of medicine or any kind of hormone, but they are getting an injection. And that, so I can see, well, maybe it's just getting a shot itself that makes rats grumpy, right? Maybe they are more likely to bite other rats in their enclosure, not because I injected them with testosterone, but because I poked them in the ball with a needle. Ouch! Okay? So I can actually look to see what the difference is between the level of aggression for animals that just get a shot and animals that get a shot that actually has something in it that should increase their aggression. And it also works with other kinds of placebos, other kinds of drugs. So if people are receiving treatment for depression and I give them what they think is a new medication and it's actually just a sugar pill, and I compare their changes in their level of depression with people who actually get a known medication, like Prozac, and look to see how the changes in depression rate compare, that's also a placebo case. So placebo is where they're going through all the steps of getting the medication except actually getting a medication or actually getting the treatment. Everything else is being done to eliminate any other aspect of the treatment, like getting a shot or taking a pill or thinking that you're getting a medication, from the treatment effect, so that we can separate that out from the actual effect of the drug or the hormone. A standard treatment control is something that we use when a no treatment control would be unethical. So again, if we go to the case of depression as an example, if you have people, you're a therapist, and you have a group of patients come to you and they're coming to seek treatment for an illness. And it's not ethical for you to say, I'm not going to treat you right now because I want to study you instead. So I want you to be in my no treatment condition. So I'm going to let you go ahead and be depressed for a little while more. Because, maybe they're coming to see you, they're probably in pretty bad shape. They might even be suicidal. It's not okay for you to deny them treatment for the purposes of science. You can't do that. So instead, what you might say is, okay, what I'm going to do is I'm going to administer a standard treatment to you. Standard talk therapy, let's say. Talk therapy is a totally reasonable, safe, recognized therapy for depression. And so what I'm going to do is I'm going to have everybody in the study experience talk therapy as part of their treatment. But in my standard treatment control group, that's all they're going to get. Then I'm going to take another group and I'm going to give them a medication in addition to their talk therapy. And so that's my experimental group. So because I'm holding the talk therapy component constant, it's now no longer an issue. But I'm not denying the control group treatment, which they've come to me seeking. And that's the ethical way to deal with that situation. Now, it's possible to have some combination of those. So for example, if I had a group of patients who are all severely depressed, and talk therapy was a recognized safe and ethical response to their depression, and I gave everybody talk therapy, and then I had, in addition, I had another group that was a placebo control, so in addition to the talk therapy, they also got a drug, but it wasn't really a drug, it was just a sugar pill. Yeah, I could do that. And then I could actually have my true experimental group where they're getting talk therapy plus the new medication that I want to check out. So I can have 3 groups in my study. 2 of them would be controls, and one would be a placebo control, the other would be a standard treatment control. And it's even possible, if you're in a situation where it's ethical, you could feasibly have a study with a no treatment control, a standard treatment control, a placebo control, and then an experimental group. You can have all the controls if you want to. It's just tiny, tiny variations in what the subjects are getting in each condition to help you tease apart the true impact of your experimental treatment. Now, waitlist control is a somewhat unusual case. This is where it's actually ethical for you to delay treatment. So you choose to delay treatment for a reason. What you do is you have, let's say, for example, we had people who were very overweight, and they were coming in to get, they wanted to get medical assistance with losing weight. They say, all right, well, we're exploring several different treatments for losing weight, and we've got these different groups of people. Each group all has roughly about the same amount of weight to lose. What we like to do, we like to have this group, Group A, okay? Folks in Group A, we're going to have you wait for a period of 6 months to begin your weight loss, official weight loss treatment. And over the course of that 6 months, we're going to have the other groups begin their treatment. And so for the purposes of this study, for those 6 months, you are going to be our no treatment control, or our standard treatment control, depending on what would be ethical to do. Okay? You're going to be our main control group. And the other groups are going to be different kinds of specific weight loss strategies, like you might have a P90X group, and a Weight Watchers group, a hypnotism group, whatever you want to do for different treatments. And for those 6 months, we're just going to gather data from all the groups, and that wait list group is going to get no specific treatment. And the reason that we do that is because, especially if you're doing a long-term study like this, you want to have a no treatment group so that you can see how things like weight, for example, naturally fluctuate over time. And if you think about it, I'm sure your body weight changes over time, right? There are times of year when you're more likely to be outside because the weather's good than when it's cold and nasty, right? There are times when you're likely to eat more fruits and vegetables because they're available at the store. There are times during the year when you're way more likely to eat sweets, like around the holidays, right? Where it's like everywhere you walk, people are like, here, have some peanut butter, and some brownies, and some cake, and some cheesecake. Oh, and have 4 glasses of wine, and, right? And plus it's cold, and so you're not moving around very much. And that's why people gain weight when the weather's cold, right? Because they're also living off of root vegetables and other things, right? They're carbo loading, building fat to stay warm, right? Because it could be 40 or 50 degrees outside. So it could be 50 degrees. So they have to carbo load to build fat reserves so they won't freeze to death if they walk outside in the 50-degree weather. And plus there's all the trees and stuff. So people's weight naturally fluctuates. And so you want to gather data about that over time so that when you look at the results for the other group, you can subtract out those natural weight fluctuations from changes that you see in their weight, because those don't actually reflect impact of their diet or their routine. It's just, this is how people's weight normally fluctuates over time. Now, the reason we call it a waitlist control group is because once that 6-month period is over and the data is gathered about the different weight loss treatments, this group now gets whichever treatment was most effective or which treatment they choose from among those that were offered. So they still get a treatment, they just don't get it as part of the study. So they're just delaying their treatment to serve as a no treatment or standard treatment control for some period of time. And then once the best treatment is identified, the one that might work best for them is identified, then they get that treatment as a reward for their patients for free, just like the other people got the treatment for free for participating in the study. Does everybody understand the difference between those 4 types of controls? Okay. Now, single-factor experiments can be set up in 2 ways, 2 main categories of experiments. We can either have a between subjects design or a within subjects design. This has to do with how we're making our comparisons. In a between subjects design, we are comparing different groups of subjects. Okay, so it's cross-sectional. We've got different subjects, different people or different animals in every condition. Okay, so group A is a totally different group of subjects than group B, and those are both totally different groups of subjects than group C and group D. Okay, there's no overlap in membership of subjects in the different conditions. That's different from a within subjects design, where you're working with the same group of subjects. Okay, it's the same subjects in every condition. And what's varying, in most cases, is the order in which they experience those conditions. Now, sometimes it's not possible to vary the order that they experience the things. But if possible, we try to vary the order in which they experience the conditions. So one group of subjects that's being tested multiple times. So between subjects is multiple groups being tested once. Within subjects is one group being tested multiple times. Now, we break up between subjects designs into different categories. You can have a random groups design, matched groups design, or a natural groups design. We're going to talk about how those 3 different types of designs differ from one another. We talk about within subjects designs. We divide it up into 2 general categories, complete designs and incomplete designs. And we're going to talk about how those are different too. And one of your jobs will be to be able to recognize from a description of a study which kind of design we're talking about. Is it between subjects or within subjects? If it's between subjects, is it random, matched, or natural groups? If it's within subjects, is it complete or incomplete? Okay, you're going to have to be able to identify what kind of study it is from certain characteristics. And we're going to practice that. So today we're going to focus on between subjects for the most part, and then within subjects we'll talk more about next time. So just to practice the distinction though, before we jump in and start talking more about between subjects, just to make sure we've got the distinction between these 2 types of designs. Let's imagine that we want to design an experiment to explore the question, the research question. Will people solve problems more creatively in groups or alone? And so we want to find an answer to that question. We want to investigate it empirically. And we want to do it using an experiment. So if I'm going to do this as a between subjects design, what would the IV be? And what would the levels of the IV be? Trying to figure out if people solve problems more creatively alone or in a group.
The independent variable would be alone in a group.
Okay, so the independent variable would be the size of the group, and the levels would be in a group or alone, right? Or it could be with, alone, with 2 other people, with 4 other people, or something like that, right? That makes sense? So this is the issue of construct validity, right? I want to make sure that I'm creating an independent variable that has levels with meaningful distinctions. It probably wouldn't make sense for me to have my groups be 1 person and 20 people. Have you ever tried to solve a problem with 20 people? It doesn't get solved. What you get is chaos, right? Which is why Congress doesn't work, right? Because there's all these people. There's like 50 people, 100 people, 200 people trying to solve a problem, and they're all stupid, right? They're all, and every one of them is sure they've got the right solution. And so you don't actually get anything done. So having 1 versus 20 is not going to be good construct validity. That's not a good way to design the levels for that. But 1 person can solve a problem. 3 people can work together to solve a problem. You've probably done that, in a family, situation where you're working with a couple other people in your family to solve a problem. Or even up, 5 people can work together. That's about as big as you want a group. That's why typically when we assign group projects in classes, we don't make groups bigger than 5. Because once you get beyond 5, pretty much what happens at that point is you get like 2 people who do all the work and everybody else just sits back and has cookies. Right? It just doesn't, you get people who, somebody's a leader or somebody's a follower and other people do the grunt work or they just don't do their job at all and stuff doesn't get done, right? So you want to define levels of the independent variable that are different but meaningfully so. So if I see a difference between 1 and 3 and 5, that's actually informative and has, makes sense. But if I did it between 1, 20, and 200, well, duh, obviously I'm going to see differences in those cases and it's going to be a disaster and I'm not going to know what's going on. Okay, that's going to be a mess. So let's say we have group size as our independent variable and our levels are group size of 5, group size of 3, group size of 1. Just as an example. Is that going to be a manipulated variable or a subject variable? Manipulated, that's right, because I can randomly assign people to the groups, right? You come into my study, I say, roll the dice, all right, it came out 1 or 2, you are in the 1-person group. Roll the dice, you come in, came out 3 or 4, you're in the 3-person group. Roll the dice, for you, comes up 5 or 6, you're in the 5-person group, right? I can totally randomly assign people to whichever group, so we've got a manipulated variable. What would the dependent variable be?
Level of creativity.
Yeah, how creatively the people in the group solve the problem. Now, how exactly you would measure that, I don't know. Creativity is one of those really smushy things, like what counts as creative? Some people think graffiti is creative. Other people think it's vandalism. Some people think hairstyles can be creative. Other people think it's just weird. Right? So, some people think that putting sequins on everything is creative, right? You can bedazzle almost anything, right? Some people don't think of bedazzling as particularly creative. They just think of it as making stuff sparkly, right? So, it depends what counts as creative. But you have to come up with some measure of creativity and then apply it to the situation. It would depend on what kind of problem you are having to solve. Now, we think about the challenges presented by this kind of design. A couple things come to mind. First of all, if we have 3 groups of subjects, we need those subjects, those groups, to be as similar as we can get them outside of the fact that there are different numbers of people in the group. So I need, for example, the people in the groups to be comparably well educated, to have comparable experience solving the particular type of problem that we're looking at. They need to have roughly the same amount of time to solve the problem so that we can make a meaningful comparison. I mean, if I give one group an hour to solve a problem and another group 5 minutes to solve a problem, and my measure of creativity is about the number of different solutions they identify, well, obviously the group that gets an hour is going to do better than the group that had 5 minutes. So we have to make sure that we're making the groups and the circumstances under which they're engaging in the experiment as similar as we can. Because any way that those groups are different, aside from the number of people in the group, we could potentially be introducing a confound that makes it hard for us to interpret the results of our study. So we really, really want to make those groups as similar as we can. One easy thing about doing a study like this with between subjects is we can use exactly the same problem in all 3 conditions, because nobody does more than one condition. So whoever comes into the single problem solver group can solve the same problem as the people who solve the 3-person group and as the people who solve the 5-person group. We can use the exact same problem. We can hold that problem constant, and that'll make the comparison easier. Now, that's not true in the case of a within subjects design. If we did the same study as a within subjects design, we can no longer use the same problem for all the conditions, can we? Why not?
Because they've all heard it before.
They would have all seen it before, right? It doesn't matter what condition they start in, whether they start in the single-person group, the 3-person group, or the 5-person group, because this is within subjects designs. Remember, this is where we test the same group of people multiple times, which would mean everybody would do the single-person condition, and everybody would do the 3-person condition, and everybody would do the 5-person condition. So if you give them the same problem, obviously they're going to get better at it the more times they work on the same problem. They might actually get less creative, right? Because they find a solution and they get stuck or something. So we'd have to switch up the problem and have 3 comparably difficult problems, or problems that could be solved in the same number of creative ways. So that could be complicated. Yeah.
I was just about to ask, how do you control for knowing if the problems are comparably difficult?
That's right. So when you do something like this, you would have to do some kind of pre-tests, where you would have people try different problems, like the same people. You have to have a different group of people, different experiment, where you basically had people come in and try different problems and rate them for difficulty. Or you would have to use some kind of standardized problems that were already predetermined to be comparably hard. Or you would have to do problems that had units that could be swapped out. So for example, if I had, you could have 3 different math problems, and all you did was change the numbers, but all the operations were the same, you know, or something like that. So you'd have to come up with some way to determine the difficulty of the problems, either pre-established or establish your own way to determine that. And if you're doing it on your own, that's a whole other level of difficulty for this study, because you have to basically figure out, how do I get 3 problems that are comparably hard?
So the within subject design is harder.
It can be, but in some ways it's easier because, again, we've got the same group of subjects experiencing all the different conditions. So I only need to get one group of people to do my study, and I don't have to worry about the groups being made up of different types of people. Individual differences, I don't have to worry about anymore because everybody's exactly the same. It's the same 25 people in every condition. So I don't have to worry about that issue in the between subjects design of making sure that the groups are comparably well educated, have comparable experience solving problems, are comparably well fed, are comparably well rested, all the other things that could influence how well they solve the problem. This is the same subjects. So all of those individual differences things disappear in within subjects, so that's easier. But then the challenge is to switch up the order, because I don't want everybody to come in and solve the problem on their own, and then solve the problem with 2 other people, and then solve a problem with 5 other people, because there might actually be something that builds, right? As you solve more problems, you might actually solve problems differently the more you practice doing it. We've all done that. If you're doing a set of homework problems in math or something, and the first ones are kind of hard, and then you kind of get into the groove, it gets easier to solve the problems. So we could have that same situation show up here. So in this case, the randomizing that allows this to be a manipulated variable is randomizing what group they started. So if everybody's participating in all 3 groups, the single solver group, the 3-person solver group, and the 5-person solver group, when people come in to the study, they're going to get randomly assigned to one of those 3 conditions as a start condition. And then once they've completed that condition, they're going to get randomly assigned to the next condition out of the 2 that are still available. And then their last one will be predetermined because they will have completed the other 2. Okay, but we can still randomize the order in which they start. And so this is still considered a manipulated variable. But other than that, IV and the levels would be the same. Dependent variable, same. What's differing is how often we're testing each subject and the circumstances under which we're testing each subject, and how many different types of stimuli we need. Do we need just one problem for them to solve, or do we need multiple ones because everybody's going to be solving problems under different circumstances? Okay. So when we are creating a between subjects design, our number one challenge, the biggest thing we have to do to make sure that we're maximizing internal validity is create groups that are similar enough to compare statistically. I need the people in group 1 to be as much as possible like the people in group 2, and the people in group 2 to be as much as possible like the people in group 3, and the people in group 3 to be as much as possible as the people in group 1. Now, there are inherently going to be individual differences in these groups because they're made up of different people. I've got 20 different people in this single problem solver group. And they're different from each other. And I've got 20 more people in the 3-person solver group, or 21 more people, the 3-person solver group. And they are going to be different from each other in some ways. And I've got 20 different people in the 5-person solver group, and they're going to be different from each other in some ways. That's just how it is. People are different. We can't eliminate all those differences. But we can try to distribute what individual differences exist as much as possible evenly across the conditions using a balancing procedure. And the way we do this most of the time is by using random assignment. That's what random assignment's for. That's why we use it. Because if you use the statistics to your advantage, you can actually get people's level of education pretty evenly distributed, and their ability with solving problems of a particular type pretty evenly distributed, and their racial and ethnic background pretty evenly distributed, and their sex pretty evenly distributed, and their ability to work with others pretty evenly distributed. All the different things that might influence how well they perform in the different groups. You can get that distributed pretty well balanced, using random assignment. Now, random assignment doesn't guarantee that that's going to happen, because random things don't always look random, right? I mean, one possible random assignment could be the 5 smartest problem solvers in the group all end up in the same group, right? And then 3 of them end up in the 3-person group, and then they all do really well in the 1-person group, right? And all the other people are terrible, right? Something could happen like that. Okay? Random assignment doesn't guarantee that we're going to get individual differences evenly distributed. It helps, and it helps more when you have a big group to work with. So the bigger the sample is that you recruit from the population at the beginning of your study, the more likely random assignment is to work for you. But if you have a really small group, like 10 or 20 people, and you're trying to divide them across 3 or 4 groups, then you might have to give random assignment a little help. There are a couple of strategies that we can use to make random assignment work a little bit better. Now, we're not replacing random assignment, we're just supplementing it, trying to make it more effective in a situation where a group is small. And the ways that you can do that include restricting the range of variation and matching. Now, restricting range of variation, you might do, if you have a set that has, you have a population that has some outliers, but there's a kind of concentrated group that's going to be pretty large and is fairly representative of the group, and you want to focus on that group. So, for example, if I'm talking about college students. Now, we have college students here at Georgia State in the psych program that range in age from 16 up to their 70s. Okay? People from all different ages taking psychology classes right now. Now, if I wanted to do a sample of psychology majors, psychology students at Georgia State, I could sample from that group. But if I get one 16-year-old, well, there aren't that many 16-year-olds, right? There just, I think there's one. Okay. And there aren't that many people in their 70s either. So I might get one, maybe. And so there's no way that I can get that kind of range evenly distributed across my groups. But if I say, you know what, what's the biggest chunk of people in this group? People between the ages of 18 and 24 is about the biggest chunk of psych majors. So college students, typically undergrads. So let me restrict my variation. Let me restrict the range of variation to 18 to 24. And say, to participate in this study, you have to be between the ages of 18 and 24. And by doing that now, by shutting out the people who are likely to have very low representation in the group, and as a result, it's actually quite hard for me to get a representative sample that includes them, because they're not even representative, they're outliers. Right? By picking kind of the core, focusing on the core of the group, restricting my range of variation to that core, then it's actually easier for me to make the groups more similar. Right? If everybody's between the ages of 18 and 24, and I've got 20 people, well, chances are I'm going to have a few 18-year-olds, a few 19-year-olds, a few 20, a few 22, a few 23, a few 24, and I'm going to be able to balance that out across the groups, and the age difference won't be so extreme, so age shouldn't be a problem. So I can do that. I can restrict the range of variation. That's one strategy. I can also use a matching procedure. And a matching procedure involves taking the subjects that I have and identifying some characteristic that they have that might be important to their performance in the study, and then making sure that that characteristic is evenly distributed across the groups. As an example, say that I'm doing a study about reading. I'm studying how well people read and have reading comprehension. Right? Well, there's some evidence that suggests that people's level of working memory influences their reading comprehension. So I might give everybody in my study a working memory test to see how good their working memory is, and then I will put them in order. The people who have the largest working memory at the top, and then put them all in order, from the highest amount of working memory down to the lowest amount of working memory. Okay. Then what I'm going to do is I'm going to say, how many conditions do I have in my study? Let's say that I have 3 different reading comprehension conditions in my study. Short passage, medium passage, long passage, for example. All right? So then what I'm going to do is I'm going to say, all right, I've got this big long list of people, all ranked in order by their working memory capacity. I'm going to take the top 3 people, okay? Highest amount of working memory, second highest, third highest. And I'm going to treat that like a group, and I'm going to randomly assign the people from that group to my 3 conditions. So now every one of my conditions in my study has one of the 3 largest working memory people in it. I've now kind of forced that characteristic to be distributed evenly across the groups. Now I'm going to take the next 3 people, so the next highest amount of working memory, and randomly assign them to my 3 groups, and go through my study doing that until I get down to the bottom of my list of subjects. And what I've effectively done is made sure that every single group has some of the people with largest working memory, some with moderate working memory, and some with low-level working memory in every single condition. So I've kind of forced working memory to be evenly distributed across the conditions. But I've still used random assignment to put them in the groups. Okay? I just gave it a little boost. Now I did an example here, because I know having me describe that in words is a little bit complicated. So I did an example here. See if I can get this to come up now. Come on, Duckcam. Is it going to work? If not, I can walk you through it. Duckcam. See, it's on. There we go. We need to project. There we go. Okay. Whoa! Really big. No, smaller. There we go. How many PhDs did it take to work it out? All right. So, I want you to pull out the handout that says Independent Measures Design. So this handout is intended to show you a comparison between doing straight up random assignment and doing matching plus random assignment. Okay? Just a handout that kind of maps it out so you can literally see subject by subject where everybody goes and how they get put into the different conditions. Now a couple times already I've talked about this study where we're going to have different dogs eat different foods. Okay? So our IV is food type, And we're going to split it up. They're either going to eat chunks and lumps, which I'll refer to as chunks, Purina dog chow, which I'll call Purina, and Kroger kibble, which I'll just call Kroger. So we've got 3 groups. Each subject is only going to eat one type of food. This is an independent groups design, or between subjects design, or an independent measures design. Those are all similar terms. I can use them interchangeably. Independent measures, independent groups, between subjects. Okay, all mean the same thing. So I've got each subject is only going to eat one type of food. I'm going to gather data from multiple subjects in each condition, and I'm going to use random assignment first to assign the dogs to the different conditions. Now to do this, I've got 3 conditions: chunks, Purina, Kroger. Okay. Just to keep things easy, we're going to say that I've got conditions A, B, and C, where A is chunks, B is Purina, C is Kroger. Okay? Is that all right? Make sense? Right. So how many different random orders are there for these 3 letters? There's ABC, that's one. What's another one?
CBA.
CBA. What's another one?
BAC,
ABA.
BAC.
ACB,
ACB.
ABA.
BCA.
CAB.
CAB. Okay. Is that all of them? Yeah, it is. And I can give you a way to check that you've come up with all the possible random orders. We have 3 conditions in this study. And if you start with that number, however many conditions you have, then you multiply it by that number minus 1,